So it changes the numbers a little bit, but we got a programmer. It's probably a human character's path of an object, and it says the object is 50 meters to the left, 30 meters in front of the character. So that implies that the character is looking in a certain direction, and the object, which is just going to be this circle, is 50 meters, 50 meters to the left, and then 30 meters in front. Okay? And then you land at the object. So if you're supposed to write that as a vector, the convention is to write the x component first, like the horizontal direction, and then the vertical component second. So horizontally, we're 50 units, and if we go left, if we go left of like a heading, like, if you're facing forward, left is considered going in a negative direction. And then the y direction, the up and down direction, vertical direction is positive if you're going forward, negative if you're going backwards. But that's the thing with vectors, with everything else really in math. It depends on what you're referencing. If the character is facing the opposite direction, then the object would be to the right, and it would be a positive 50. And it would be a negative 30 because the character would have to back up, have to go backwards. So, okay, so we got part one, we got the vector. How far is the object from the human character? There is a formula for the magnitude of a vector. All it is the Pythagorean Theorem, though. Okay, so here, this is 30, this is 50. So the formula is when you square both components and then take the square root of their sum. So 50 squared plus 30 squared. But if you use the Pythagorean Theorem to find the hypotenuse, then you've got it. Okay, so 50 times 50, 2,500. So we got 3,400, and we need the square root of that. So if you know me, and if you've been watching my videos, I'm not big on decimals unless we're plugging them in some software online. So you can carry out however many decimals you want, but it's 58 meters, roughly. Okay, part three is the question students are usually asking me about. So a second character is 20 meters to the right of the first character. So this is 20. And 15 meters ahead of the first human character. So it's over here. 20 meters to the right, 15 meters ahead. So this should be further. There's a second character. Okay, so this hypotenuse that I drew, this is the vector, negative 50, 30 from our origin. So we can make a vector for this, the straight distance to this second object. This would be 20 to the right, x component first, y component second. This is 50 forward, so that's positive. Make it face the second human. What is the angle of rotation needed? Okay, so from this first part of the problem, we found out the angle of we're looking straight forward, right? I'm pausing because I think I said something wrong to a student today because I forgot that the character's facing forward. Wait, did they ever rotate? No, they never rotate. So this is the direction that the character is facing. You could call this vector 0. Here, I'll draw it up here. It's red. You can call this vector 0, 100, and that would be a vector with a magnitude of 100, right? You could call it 0, 1,000. All those vectors have the same heading, right? They're facing straight forward from this character, so the y component is free. So you could call it 0, 1 if you want. Okay, because all we really need to do is have two vectors so that we can find out the angle between them. You could also use right angle trig. But what I've been pointing students to is the angle between two vectors, which is what we've been doing a little bit in Newton this week. So you could use these formulas. I'll use them in just a second. I think you could get away with just using right angle trigonometry here, right? Because we want to know. Yeah, so the hint down here says you could create a vector between the first and second human. So this is bad writing. I should have wrote that the character is facing the first human. So I'll mark it correct no matter what people do. You could use this as your first vector. This is the second vector, and your goal is to find out the angle between them. If you do the problem that way, I'll mark it correct. Okay, but the hint is pointing you towards the character facing this object. So the object's vector was negative 50, 30. And then the second character, the vector to the second character for my problem, because I changed the numbers, is 20, 50. Okay. So again, just one last time, since I didn't make it clear, since I didn't say that the character is facing the object, what's the angle of rotation to face the second human? You could do it this way if you have already done it. So if you're watching this video and you're like, oh, I messed up, you're fine. I'll take care of it for you. Okay, because the big point is supposed to be finding the angle between two vectors. You could use either one of these formulas. I'm going to use this one because the dot product is usually a little bit more straightforward for students. If you want to find the dot product between these two vectors, what you do is you multiply the corresponding components. So negative 50 times 20 is negative 100. And then you add that to the dot product of the other components. So 30 times 50, 150. Wait, 0. No, I got that wrong. 1,000. Yeah, okay. I got it the second time. That's the dot product. And in this website I used, the dot probably should be higher. That's all you have to do for the dot product. And these bars in vector notation isn't the absolute value, it's the magnitude. So it's how long this vector is and how long this vector is for B here. The magnitude of this vector, if you want to find the magnitude of this vector, then you use the Pythagorean theorem again, right? It's the square root of each component squared. So this is 50 times 50. I think we've already done this. I'm getting deja vu. Oh, wait a second. We already did that. Yeah, that was part 2. Okay, so 58.3 roughly. That's the magnitude of the first vector. And then the magnitude of the second vector, that's going to be 50 squared plus 20 squared. And then take the square root. So the magnitude of the second vector should be less. And it is, yeah, because this component's closer to the origin. So 53.85, something like that. That's the magnitude of the second vector. Okay, so we need that down bottom. And then this is 58.3 over here. Times that. And then we can simplify now. So negative 1,000 plus 1,500 gives us 500 in the top. And then on the bottom, 8.3 times 53.85, 3,139 some change. And then you can finish simplifying. Divide the top by the bottom. Is 0.159. So what we've done is we found out the fraction that cosine is equal to. Okay, we just found that cosine theta equals 0.159, and now we're finally ready to find the angle. To get theta by itself, we need arc cosine. We need the inverse of cosine. Okay, so here's our result. We're going to use second cosine, and there's our angle. 80.83 degrees is the rotation. So that's the end for part 3. Okay, so I'll send out a message to the class because it is ambiguous. Like, I didn't say at any point that you rotated to face the second object, but that's what part 3 was supposed to mean. So if you did it this way using a vector that's going straight forward, you're fine. It's okay.